In today's lesson, we'll be exploring how to find factor pairs using a factor rainbow. We'll also be exploring prime and composite numbers.
Well, hi there. How's it going? Our day's going pretty good. Me and Axel are about to eat our favorite snack, Cheez-Its. I could literally eat Cheez-Its all day. Axel loves them so much too, they even have a dog version. Check this out. They literally look the same. The amazing thing about Cheez-Its is you can eat a lot in one sitting and not even get sick. So that leads me to a question. I'm eating 18 Cheez-Its. How many equal groups of Cheez-Its can I make? How am I supposed to figure that out? We gotta figure out the factors. What's a factor?
Factors are numbers you can multiply together to get a product.
Every multiplication equation has factors.
And two factors that give you a product are known as a factor pair.
Now let's go back to the problem with the Cheez-Its. Don't think I forgot about that one. I have 18 Cheez-Its that I want to partition into equal groups. I want to figure out how many equal groups I can make. So I'm going to figure out my factor pairs. Ooh, now here's the cool part. I got a special strategy just for you. Something called a factor rainbow. Close enough. It's called a factor rainbow because when you think about it, a rainbow connects two sides. When trying to find a factor pair, we think of what two factors can multiply together to get our end product. In this case, it's 18. This Jewell has 18 Cheez-Its. She wants to partition into equal groups. My helpful math tip is to always start with 1. Everything can multiply by 1. So to get 18, I can multiply 1 and 18. This is a factor pair. I then like to think of my skip counting and start with my next number. My next number is 2. Does 2 multiply by anything to get 18? If I don't know what multiplies by 2 to get 18 right off my head, I can use skip counting to help me figure it out.
2, 4, 6, 8, 10, 12, 14, 16, 18, 9!
That's right, 2 and 9 are also a factor pair of 18. Let's keep the train going. What about 3? Is 3 a factor pair of 18? Skip count it. 3, 6,
9, 12, 15, 18!
you said 3. So 3 and 6 are factor pairs of 18 as well. Let's not stop there. Can 4 be a factor pair of 18? Skip count. 4,
8, 12, 16, 20.
4 is not a factor pair of 18. What about 5?
5, 10, 15, 20. I definitely didn't say 18.
And then before you know it, you're already at 6 again, and we already knew that 6 was a factor pair of 18. So as you can see, when you look at the factor rainbow for 18, 1, 2, 3, 6, 9, and 18 are all factors of 18. Just like Skittles, you can taste the rainbow. That's incredible! And if you look at the factor rainbow and follow the arches, you can see all 3 of the factor pairs. 1 and 18, 2 and 9, 3 and 6. Bottom line, there's so many groups of Cheez-Its I can make. So here's another point I'd like to make. 18 has multiple factor pairs, 3 to be exact. Dang, that's a lot of factor pairs. So a number that has multiple factor pairs, meaning more than 1, it's something called a composite number. And the way I like to remember that is composite loves company. Axel's great company. I love company. It's fun to have someone else around. Right, buddy? So 18 is a composite number because it has so much company. 1, 2, 3 people to the party. In contrast, some numbers don't have any other factor pairs besides 1 in itself. Those numbers are called prime numbers. Repeat after me. P-R-I-M-E. The only factors are 1 and me. An example of a prime number is 3 because its only factors are 1 and 3.
Miss Jewell, I'm starting to see a trend that all odd numbers are prime numbers. Is that true?
Oh, my young Padawan, you have so much to learn. Take a look at the number 9. Let's find its factor pairs. Like all numbers, it's for sure going to have the first factor pair of 1 and 9. Then I skip count. I know it's an odd number, so 2 can't be a factor. So let's try 3.
3, 6, 9.
That's right. 3 has another factor pair of 9 because 3 times 3 is 9.
That's a composite number.
So that's all, folks. Thanks again for joining Math with Miss Jewell. I'm going to go enjoy my Skittles. Bye!